All right, we're going to be talking about addition, okay? And before we talk about addition, let's talk about the steps of solving an equation, okay? All right, so let's look at this equation that has addition. It says x plus 3 equals 7, okay? Remember, variables mean a question mark. So we're saying, I don't know, something plus 3 equals 7. What plus 3 equals 7? I don't know. That's the question. Now, some of you may have solved this in your head already, and you know the answer, right? But this is what an equation is asking us. Something that we don't know plus 3 equals 7. And to solve this, okay, we need to do two things. One, we need to move all the variables, okay, to one side of the equation, okay, and we need to move all the numbers to the other side. Okay? So we need to move all the variables to one side and all the numbers, okay, to the other side. And it doesn't matter, variables could be on this side, numbers can be on this side, or variables can be on this side and numbers on this side. All that matters is that we separate these two. So all the numbers, whether it's constants or coefficients, are all going over here, and letters are all going on the other side. All right? So with addition, we're looking at moving this number right here, okay, over to this side, right? And to do that, we're going to use subtraction. So addition uses subtraction, okay, not surprisingly, okay. It's going to use what's called the opposite, the inverse operation, right? So we're going to use subtraction. So what we're going to do here, we're going to make this number go to 0, right? Because when it goes to 0, then x will be by itself, because anything plus 0 is itself, right? 5 plus 0 is 5, 2 plus 0 is 2, right? So I want this just to be by itself. How do I make 3 go to 0? I subtract 3, okay? So 3 minus 3 gives me 0. Now, equations, all right, are like a balance, okay? These are the same on both sides, and this is lovely and balanced, okay? This is our equal sign, okay? Our equal sign says that this side and this side are exactly the same. And what I had over here is I had x plus 3, and I had 7, okay? So now I have subtracted 3 from this side, okay? Now this side has gotten lighter, and unfortunately, I now have a balance, something that's going like this, okay? I have subtracted 3. I've taken this off, and instead of being nice and balanced, this side is now lighter. Oops, that's the opposite. Let's try this again. Not lighter. It's a lighter would look like this. Let's figure out how to use a balance, okay? It would be, now it's like this, because this side is lighter and this side is now heavier, okay? Because I have subtracted 3, right? I was balanced like this, I took something off, and now this is lighter and this is heavier, right? But the equal sign means that they need to be balanced. They need to be the same, all right? So if I subtract 3 from this side, I have to subtract 3 from that side, all right? Because that is going to bring me back into balance, all right? So I subtract 3 from this side. It throws me off balance. I subtract 3 from the other side. It brings me back into balance, this nice straight line. So if you could imagine that I had this lovely pencil and I was trying to see if I can actually balance it. I doubt I can because it's kind of funky. All right, and I'm trying to balance it on my finger, right? I'm pretending I'm balancing it, right? If I subtract 3, it ends up being out of balance. So I subtract 3 from the other side, and now I'm back in balance, all right? It's a very important concept with equations. Whatever operation you do on one side, you have to do to the other side. You cannot subtract, multiply, or divide just one side of an equation, okay? you have to subtract, multiply, and divide to both sides every time. Okay, so I subtracted 3 here, threw me off balance, subtract 3 from this side, and now I'm back in balance. Okay, so what I have is I have x, right, and now this goes to 0. So I actually have x plus 0 equals what, 7 minus 3? And that is 4. So now I don't need to write the 0 because something plus 0 is always itself. So I have x is equal to 4. All right, let's look at another one of those. All right, see if I can get my balance right. It's funny. All right, so let's look at, how about x plus 2 is equal to, I don't know, how about 4? All right. All right, I need to, once again, what were those steps? I need to put all the letters on one side, and I need to put all the numbers on the other side. Okay, and I'm using addition here, so I'm going to use subtraction, right? Because I want this to go to 0. Right, so subtracting, because I need this to go to 0, 2 minus 2, gives me 0. So that's great. So here's my balance. I had x plus 2, and I had 4 on this side. I subtracted 2 because I wanted this to go to 0, and I accomplished that. But I'm out of balance, right? Now my balance beam is something like this, right? It's not a balance beam, it's just a balance, okay? And so what do I need to do to put this back into balance? I need to subtract 2 from this side, right? So here I go, subtract 2 from this side. 4 minus 2 gives me 2. So now I have x plus 0, right, is equal to 2. I don't need to keep that 0 around because it doesn't do anything. So now I have x is equal to 2. All right, let's look at another one, and let's look at it and have it look a little different for us. All right, and let's maybe throw in a negative number. How about if I have negative 3 equals x plus 4. All right. Whew. Okay, I've flip-flopped it around, and I've thrown in a negative number. It's exact same steps. Remember, all the letters on one side, all the numbers on the other. All right. My letter is already on this side, so I'm going to keep it on this side. All right. So I have my lovely balance here. I have x plus 4, and I have negative 3. I have addition here. I need this to go to 0. I need it to go to 0 because I need the x all by itself. To make this go to 0, I am going to subtract 4 because 4 minus 4 is 0. So here I am. I've subtracted 4 from this side of the equation, right? That throws me out of balance, right? Now I'm something like this, right? This side is heavier, sort of. Let's not get into that. But I need to subtract 4 from this side, all right? All right, so here I go. Subtracting 4 from negative 3 should put me back into balance. I need to move this out of the way. All right? Subtracting 4 from both sides, negative 3 minus 4. Okay, that might be a little challenging, and if it is, throw it into your calculator. Negative 3 minus 4 gives me negative 7. So I end up with x plus 0 equals negative 7. All right, let me get rid of these guys. It's kind of confusing. And I don't need to keep that 0, so I end up with x is equal to negative 7. All right, this is the same as x equals negative 7. You can flip and flop these back and forth, okay? It doesn't matter, right? Either way, back and forth, these are the same. Negative 7 equals x equals negative 7, all right? So that was a little bit different, all right? All right, so there are some even more challenging ones on there. Maybe I'll throw one more on there. What if somebody has plus a negative? So what if we have y plus negative 2 equals 4? It's still a plus, right? But someone threw a negative in there. All right, I need this still to go to 0. What plus negative 2 equals 0? Okay, and that is positive 2. So I'm adding 2. So if I have a negative 2, so if I'm down the number line, right, down here at negative 2, to get up to 0, I'm actually adding 2 because I'm trying to go to that 0. Negative 2 plus 2 gives me 0. Now remembering, here I was, y plus negative 2, and then I had 4. When I added 2, it actually threw me out of balance, all right? And so I need to add 2 to this side to get back into balance, all right? So I added 2 to this side. I need to add 2 to that side to keep that nice balance. So adding 2, let's go ahead and get rid of this, all right? Y plus negative 2, right? So I added 2 to get up to 0, 1, 2, add 2 to this side, gives me 6. And I'm okay if you get comfortable enough to drop off the plus 0 part, that is fine. You can go ahead and say y is equal to 6, okay? All right, so let's look at our workbook page quick. And in this book, it's page 32. All right, so we have 16 different problems to work on. They all use addition. I did throw some fractions in there. I did throw some decimals in there, so do your best with that. Some of the fractions have common denominators. Some of them do not have common denominators. So that's a lovely little practice for you there. Calculators can work fractions, all right? Probably not going to throw that in this video, but if you've been in my other classes, we have worked some of those before. All right, so let's just look at number 1 quick. X plus 3 equals 5. All right, so working those one-step equations, I need to get all the letters to one side and all the numbers to the other side. All right, so I'm going to subtract 3 because I want this to go to 0. If I subtract 3 from that side, right, if I subtract 3 here, then I had better subtract 3 over there, right? So subtracting 3 from here, 5 minus 3 gives me 2, and I end up with x plus 0 equals 2, which is the same as x equals 2. And once again, I'm okay if you can move past this step. You're welcome to skip that step, okay? But these, I want you to do these steps right here, okay? I don't want you to do them just in your head. Normally, I'm like, go ahead, take shortcuts, but with equations, it's important to practice the steps, okay? So give page 32 a try. Of course, tell me if you find any mistakes because this is the beta version and there will be lots of mistakes. So thank you to everyone who's been sending me mistakes that you find in the answers so that I can get those fixed. Okay, give them a try and give me a heads up.